The equation for a direct variation is y equals kx, which means in order to figure out y, you just multiply x by some constant k. And so we call k the constant of variation because it's the same and it never changes. So in order to write an equation for the first one, it's a direct variation because it says y varies directly as x, so we're going to use the equation we just wrote down, y equals kx. Our job is going to be to figure out what the constant is. So what we're going to do is take the 14 for y and plug it in, and we're going to take the 3.5 for x and plug it in. That way we can solve for k. So we're trying to figure out what that constant is. In order to solve for k, we'll divide both sides by 3.5, and we get 4 equals k. So now all we have to do is just plug that in so we can write our answer. Y equals 4x. So that's the equation. We can graph it by a couple methods. We could say it's in slope-intercept form, y equals mx plus b, and graph the y-intercept, which in this case would be 0. So we could start at 0, and we could go up 4 over 1. That would be one way to graph this. Another way would be to make a table of values, x and y. My advice is to pick a few negative numbers, 0, and a few positive numbers. So if we were to plug -2 in for x real quick, we'd get -8. If we were to plug -1 in for x, we'd get -4. If we plug 0 in for x, we'd get 0, and then we would get 4 and then 8. So when we plot all those points, we will end up with the same line that we got before. Try to show at least a few dots on the negative side and a few on the positive side. When you solve example B for k, you get 0.5, which means the equation will be y equals 0.5x. So a couple ways to graph this. We could do slope-intercept form and start at 0. 0.5 is the same thing as 1/2, so we could go up 1 over 2, and that would give us the line. Or we could make a table and plug in various values for x. Maybe we pick a bunch of numbers that you can divide by 2, so maybe -4, -2, 0, 2, and 4. You can also type the equation into the calculator and look at the table by pressing second graph. So -2, -1, 0, 1, 2, and we'd get those same points that are right on that line that we had. Whoops, right there. The equation for inverse variation is y equals your constant. This time it's not multiplied by x, this time it's divided by x. So when we look at example 2a, we're going to write an equation for when y varies inversely as x. So we'll use y equals k over x, and we'll do the same thing we did before. We'll take the y and the x and we'll plug them in there and there, and we'll solve for k. So we have 3 equals k over 8. In order to solve this for k, since it's being divided by 8, we have to do the opposite of that and multiply on both sides. So we get 24 equals k. Now we can write our equation. It's y equals k over x. If you were to type this in the graphing calculator and look at the graph, it's going to look something like this and this. It's not going to be good enough for you to just draw some random swoops on your graph, so you need to show me that you have at least 2 points for each curve. So you can go to the calculator, type in the equation into y equals, and look at the graph, and just scroll through the table till you find some good points, or you could just use some common sense. What kind of negative numbers can you divide by 24 divide into 24 that would fit on the graph. Well, I know if I divide 24 by -6, I'd get -4 for the answer, and -6, -4 will fit on the graph. So I also can divide 24 by -4, and when I do that, I'll get -6 for the answer. So there's 2 points, and I'm going to draw that curve. If you look on the calculator, next to 0, you'll see error, because you cannot divide numbers by 0. It's undefined. That's why we have this curve. It can't actually cross over when x equals 0. So what your graph is going to do is it's going to get close to it, but it's never actually going to cross it because it's an error. So then we need to pick 2 positive numbers that we can divide 24 by. And why don't we just go ahead and pick +4. When we divide 24 by 4, we get 6. And let's go ahead and use 6. So we can plot those 2 points, 6, 4, and 4, 6. And when we do that, I'll draw the curve like that. Make sure you don't draw a straight line, because if you were to draw a straight line through your dots, then people would think that it would eventually cross that y-axis, and it doesn't. So make sure to draw those curves. When you try B, you should figure out that k equals 40. So the equation here is y equals 40 over x. So now you can look at the table, and let's try to think about numbers that we can divide 40 by that will be somewhat close to being on the graph. If you pick -8, then you'll see -5 is next to it in the table, or 40 divided by -8 is -5. So it falls off the graph a little bit, but that's just going to have to work. And if those two work, then we certainly can try -5 and -8. So we can plot that, and that also falls off the graph. But we have 2 points, I'm drawing the curve, and that's good enough. At 0, we have an error, and since I picked those points on the negative side, it's pretty much going to be the same thing, but on the positive side. So positive and positive. So I'll plot those, 5 over 8 up, and 8 over 5 up, and draw the curve just like that. If you're given a table and you want to figure out if you have direct variation or inverse variation, there's 2 tests you need to do. The first one to figure out if you have direct variation is I just took the direct variation equation and solved it for k. In order to do that, you would divide both sides by x. So the constant is the number you get when you do y divided by x. If you take all the numbers in the table and do y divided by x, and you get the same number every single time, your function will be direct variation. If you don't get the same number every time, then try the inverse variation equation. Here's the equation. If I solve it for k, I'd multiply both sides by x, which means that k equals x times y. So if you multiply x and y together, and you get the same number every time, if you get a constant, then you'll have inverse variation. If neither of those work, then your answer will be neither. So let's go ahead and try, let's see if 3a is direct variation. So I'm going to take all the y's and divide them by all the x's. So 9 over 3, that's 3. Now I'll take the next set, 24 divided by 8, and I get 3. And the last pair, I'll take 30, divide it by 10, and I get 3. Since I got the same number every single time, and I was doing that, then this is a direct variation function. Let's try 3b. I'm going to start by dividing all of those. 8 divided by 4.5, I think it's like 1 point something. 3 divided by 12 is 0.25, so already we're not getting the same numbers. So it's not going to be direct variation. So let's try multiplying the x and y together. So 8 times 4.5 is 36. 12 times 3 is 36, looking good, and 12 times 18 is 36. So since I got the same number every time, it means that this is inverse variation. All right, last example. We are going to use a direct variation equation, so y equals kx, to figure out how long it would take sound to travel 10,720 feet if we know that the speed of sound goes 335 feet per second. So sound always travels through air that fast. So the 335 is a constant. So that's letter K. That's what we're going to plug in for the K. Our other two variables are distance and time. Just to make this problem make a little more sense, I'm going to use d for distance and t for time. So instead of using the y and the x, let's say the distance, d, varies directly as time. So d equals kt. We already know what k is. That's the 335. And they told us the distance. They told us the distance it travels is 10,720. All we need to do is figure out how long. We're trying to figure out the time. So one step to solve this, divide both sides by 335. And when you do that, you get the time it takes is 32 seconds.